Hey everyone, my name is Frank Jurassic and I did my report on apportionment.
Hello everyone. Today I decided to do my report on apportionment. The first method of apportionment ever used was the Jefferson method, and that was created in 1790, while the Hamiltonian method, which rivaled each other later on, was developed later that same year. The Jefferson method was used and gave a fairly large advantage to states with a bigger population like Virginia and New York, while handing a huge disadvantage to states like Rhode Island and Kentucky. This method added up the total population and divided by the districts needed. One district equaled 110 people, so you would take the total population and divide that by 110, leaving you with a decimal usually. That decimal was rounded down, which meant that the smaller states did not find equal representation. If we apply the same quotas to the Jefferson method, State A having 696 people, State B having 268 people, and State C having 136 people, but divided by 135, this gives us 5.16, 1.99, and 1.01. That means that State A gets 6 representatives, State B gets 2 representatives, and State C gets 2 as well. But if we use the Hamiltonian method, you can see State C getting 1 more representative than using the Jefferson method. The Hamiltonian method is often referred to as the New Jersey Plan. This method focused on smaller states and tried to give them equal representation regardless of their state populations. Here's a formula from the Hamiltonian method. Imagine there are 3 states, State A with a population of 696, State B with a population of 268, and State C with a population of 136. This gives us a total population of 1,100. There are these things called ideal district sizes, which is a population of 110. That's the perfect district size. So if we divide the total state population by the ideal district size, then we will get the number of seats each state should get for the representatives. So if we divide 696 by 110, 268 divided by 110, and 136 divided by 110, we get 6.33, 2.43, 1.24. Now, these numbers are rounded down, and that means that we only have a total of 9 instead of 10. And the way that's determined is by whichever decimal is higher between the states, like 0.33, 0.43, and 0.24, they get the extra representative. So the 0.43 gets the extra representative between the 3. There are paradoxes to be found when using apportionment. The Alabama paradox was the first paradox ever found. The House of Representatives is required to allocate seats based on population, and it was found that Alabama would get 8 seats with a House size of 299, but only 7 with a House size of 300. The paradox basically says that a total number of representatives is reduced for a state because of the addition of 1 representative to the House. This occurs by increasing the number of representatives for larger states faster than that of smaller states. If population for State A and State B overtook the population of State C, then this would cause State C to lose a seat, and because of that mistake, the Hamiltonian method is no longer used. There's another paradox found called the new state paradox. For each state, there's an assigned number of representatives, and if a new state enters, then the theory is that this would reduce the existing number of representatives in the current states. But this is actually solved by apportionment rounding and actually gives the existing states more representatives instead of losing them. The final paradox found is called the population paradox, in which 2 states have growing populations. Even though the smaller state is growing faster than the large one, the small state can still lose representatives. The state receives more reps based on the highest decimal, such as 0.67 over the decimal 0.34. The Jefferson method was used until 1840 and was overtaken by the Hamiltonian method, which was also called Vinton's method by some. The Webster-Wilcox method overtook the Hamiltonian method in the 1930 census. Today, we use the Huntington-Hill method, which is a modified version of the Webster's-Wilcox method. These two are basically the same, except the Huntington-Hill method uses a different rounding method. While Webster's rounds at the nearest decimal, Huntington-Hill rounds at the geometric mean. The geometric mean is the typical value of the set of numbers by using the product of their values. If a state's quotient is higher than that of the geometric mean, then it will be allocated an additional seat. As you can see, apportionment has changed throughout the years. These methods are changing ever so rapidly with our world as the world continues to grow.
Thanks for watching my report, guys. I really hope you liked it.